So now that we've looked at vertex form, we're going to go into our next form of quadratics, which we call standard form. So standard form of a quadratic is just ax squared plus bx plus c. It's the same sort of standard form that we've talked about before, where whenever you have a polynomial, you write the highest exponent first. Well, for a quadratic, it's always going to be x squared. So the x squared comes first, and then the x term, and then your constant, which doesn't have an x, or doesn't have a variable. So standard form has the letters a, b, and c. Similar to our linear equations, they had standard form ax plus by equals c. Right, but now we have lowercase and it's y equals form. Okay, this a is the same a that we saw in vertex form. Right, so if a is positive, it's going to open up. So you know it's a normal U shape. If a is negative, you know it opens down. So positive opens up, negative opens down. Now, if you recall, there are important points that you need to have whenever you're graphing a quadratic. The most important point is your vertex. All right, so in vertex form, it was easy to get the vertex because it just gave you the vertex. In standard form, we have to find the vertex, and it's kind of a two-step process. The first step is to find the axis of symmetry. So we're going to find the very middle of our graph, and then I know that on the axis of symmetry is going to be my vertex. So if this were the middle, I know that somewhere on my dotted line is going to be the vertex. Okay, so to start with, we're going to find the axis of symmetry, which we label AOS. And remember, your AOS is an equation because it's a vertical line, so it's x equals, and our formula is negative b over 2a. And this b and a that we're talking about comes back to whatever b and a are in your standard form equations. You're not going to have an equation that has a, b, and c in it. It's going to have numbers like 2x squared plus 5x plus 6. Okay, so we start by finding the axis of symmetry. Then I know because it's on that x line, that's going to be the x value of my vertex, just like before. Whenever we found our vertex, we knew the x was the axis of symmetry. So to find the rest of my vertex, I'm going to plug in whatever I got for my axis of symmetry. And I'm just going to plug that back into my standard form equation. Once you know x, plug it in, you find y, and there's your vertex. Okay, now I know that this axis of symmetry is the middle of my graph, which means if I have a point on the left-hand side, that exact same point is going to be reflected over on the right-hand side. So an easy point to get is your y-intercept. Okay, so your y-intercept is going to be whenever you plug in 0 for x, because it's always 0, comma, something. Right, so if I were to plug in 0 for x, 0 squared is 0, 0 times anything is 0, so that term goes away. 0 times anything is 0, so that term goes away, and I'm left with whatever my constant was, whatever the c value was. So your y-intercept is always going to be 0, comma, c, whatever your c value is. So for example, if my y-intercept was 1, I would have a point there, 0, 1. And then once I have it one point on the left-hand side or the right-hand side, I can just reflect it over to get my other point. So if this were 3 away, I could go 3 on the other side and put my y-intercept, and there's my rough-looking parabola. Alright, so we find the axis of symmetry, plug it in to find the rest of the vertex. We find our y-intercept, which is always c, and then we reflect the y-intercept to get a third point, because you have to have 3 points, including your vertex, to be able to graph a quadratic. So here is a quick summary. Alright, vertex form, you just find your vertex, HK. Right, then you're going to use your A value to find your next 2 points. Right, remember, if our normal graph went from your vertex up 1, right 1, and if you were stretching that by 2, instead of going up 1, right 1, we would go up 2, right 1. So it's going to be a skinnier graph. Okay, or you can make you a table of values, but you have to have 3 points. Standard form, we find the AOS first, which is x equals negative b over 2a. That's our formula. It's not a negative x, it's just a dash. Then you find your vertex by plugging in whatever you got for x. Then you find your y-intercept, 0c, and then you reflect it over your axis of symmetry to get your third point. So for example, I want to graph 2x squared minus 4x plus 2. So step 1, find my axis of symmetry. So I have to do negative b over 2a. For this example, my a is 2, b is negative 4, and c is 2. So negative b would be negative negative 4, and then 2 times 2. Well, negative negative makes a positive. 2 times 2 is 4. 4 divided by 4 is 1. So my axis of symmetry, the very middle of my graph, is at x equals 1. So I'm going to put my dotted line. Now I'm going to take 1 and plug it back into my equation to find the vertex. So we have 2 times 1 squared minus 4 times 2 plus 2. Order of operations tells me to do the 1 squared first. So 1 squared is 1. 1 times 2 is 2. Negative 4 times 2 is negative 8. And then a positive 2. 2 minus 8 is negative 6. And negative 6 plus 2 is negative 4. So that means my vertex is at 1, negative 4. Go on my graph, on my axis of symmetry, down to negative 4. And there's the very middle of my U. Now I know this one's going to be a U shape because this is a positive 2. So that means I'm going to be opening up and making a U as opposed to a mountain. Okay, so there's 1 point. I need 2 more. So next I'll find my y-intercept. Well, my y-intercept is always just c. So in this case, my c is 2. So my y-intercept is at 0, 2. There's my second point. I know I can reflect that over, and it's 1 away from my axis. So I'm going to go 1 more on the other side to get the reflection. And we have a very skinny quadratic. Domain for every quadratic, all real numbers, every single time. The range, in this case, it's going up to infinity, so that always goes on the right-hand side. And the lowest point is at negative 4. And we put a bracket because we have a value there, not an asymptote. And for our second example, we've got negative 3x squared minus 12x minus 5. So I know this negative out front for a means it's going to be going down, so I'm going to be making a mountain. So my a is negative 3, b is negative 12, and c is negative 5. So I find the AOS first. X equals negative b over 2a. Negative b is negative negative 12, and then 2 times negative 3. Negative negative makes a positive. 2 times negative 3 is negative 6, and 12 divided by negative 6 is negative 2. So the middle of my graph is at negative 2. I'm going to take that and plug it back in. So I have negative 3 times negative 2 squared minus 12 times negative 2 minus 5. Order of operations, exponents first. So negative 2 squared is positive 4. 4 times negative 3 is negative 12. Negative 12 times negative 2 makes positive 24, and then minus 5. Negative 12 plus 24 is 12, minus 5 is 7. So my vertex is at negative 2, 7, which is going to be off my graph a little bit. It's going to come up maybe like right there. And then I find my y-intercept, which is 0c, which in this case is 0, negative 5. And now I want to reflect it to the left because I want to get on the other side of my axis of symmetry. So it's 2 away, so I'm going to go 2 on the other side. Okay, graphing quadratics is just a process, and that was a terrible parabola. But it's the same process every time. If it's in standard form, it's the AOS, plug it in, y-intercept, and reflect every single time. Domain, always all real numbers. Now this one's going down, it's opening down, so I'm going to negative infinity. So that always goes on the left-hand side. And then I have a maximum point at positive 7 with a bracket. And that is graphing in standard form.